previously we were looking at this thing called arithmetic progressions. Okay, and we learned that arithmetic progressions is a series of numbers that is either increasing or decreasing. But the most important thing is the pattern. Okay, the pattern in which they increase or the pattern in which they decrease. So for example, 2, 5, 8, 11, 14, and then you kind of know what is the next number already. Okay, so this is an arithmetic progression because the pattern remains the same, which is plus 3, plus 3, plus 3, plus 3. Okay, whether it is increasing or decreasing. Okay, decreasing, for example, 99, 96, 93, astaga, 93, 90, 87, and you know this one. Okay, so this one, the pattern is minus 3. So everything is minus 3, minus 3, minus 3, minus 3, minus 3. Okay, and this pattern, okay, we call this the letter D, which is the common difference. Okay, and then from these two, the letter A and the letter D and the letter N, we learn two important formulas, which is Tn, okay, which is the nth term. Okay, the number what punya number lah. Okay, the number what, T semua kan number, okay, is A plus N minus 1 times D. Okay, we can use this formula to find any term that we want. So let's say, for example, in this one, you want to find the fifth term. Oh no, sorry, you want to find the 75th term. So 75th term is T75. Okay, so T75 means the 75th number is which number? This is the first number, this is the second number, this is the third number, this is the fourth number, fifth number, and so on. So we want to find the 75th number, right? We can continue lah. If you want, you can continue until 75 also can. Or you can use this formula. Because all you need is just two numbers, which is what is the first term and what is the pattern. Okay, the common difference. So those are all the things that we studied before the holidays. Okay, which I'm not sure if you have answered the exercise questions in the module. Okay, but if you haven't, no worry. Okay, we will do this at the end of the chapter. But right now, I want to move on to the second type of progression. Okay, so very early on, I taught you that the plus or minus pattern is called the arithmetic progression. Okay, which we saw over here. Okay, everything is plus, minus, plus, minus. But if your progression has to use a times or divide function, okay, operation, times or divide operation, okay, then we call this a geometric progression. So now the formulas will be very different already. Okay, but the most important thing is still the same, okay, which is the pattern. Whether it is plus or minus, times or divide, the number increase or the number decrease, the pattern is always the same. The pattern doesn't change halfway on. Okay, so let's come back to this. So for example, let's say I give you a progression. Okay, I say 2, 4, 8, 16, 32, like this. Okay, can you figure out what is the next number? Okay, 64. How do you get 64? But actually it's times 2. Okay, so the pattern is multiplied by 2. Pattern is multiplied by 2. Pattern is multiplied by 2. Always times 2. Because now this is geometric progression. So it's different. Arithmetic progression is plus minus. But now this is times and divide. Okay, let me give you another one. So I have to use my calculator. Sorry. Okay, 7, 28, 112, 448. Okay, what is the next number? 1792. Okay, how do you get 1792? What is the pattern? Okay, the pattern is multiply by 4. So it can be multiplied any number one, no? Can be multiplied by 4, can be multiplied by can be multiplied by 5, can be multiplied by 10,000 or so, like if you want. But the point is this, this is still a progression. Okay, this is a progression where the number is getting bigger and bigger, but it is getting bigger because the pattern is not plus minus. The pattern is times. Okay, times or divide lah. Okay, let's try another one. Let's say 99. Sorry, wait. Okay, 33, 11. Okay. What is the next number? Okay, it's 11 over 3. How did you get that? Okay, the pattern is divide by 3. Okay, divide by 3. Okay, so what happens after 11 over 3? 11 over 3 divided by 3, what do you get? Okay, you get 11 over 9. Okay, you can go on and go on and go on and go on. Okay, because progressions always never end. Okay, so this is one thing that I want to remind you all. Okay, when we talk about progressions, I know I said times and divide. Okay, but actually it's better if you just use times only. So for example, this one, we know that it is divide by 3. Okay, 99 divided by 3 is 33. 33 divided by 3 is 11. 11 divided by 3 is 11 over 3, and so on and so forth. Okay, but let's change it a little bit. Instead of saying divide by 3, we say times 1 over 3. Okay, I want to standardize everything. I want to standardize the pattern. So instead of saying times and divide, you either times the number or you times a fraction. Okay, so times number or times a fraction. So if it is times a number like this, okay, if it's times a number, the number gets bigger and bigger and bigger. But if you multiply with a fraction, okay, I know we say divide by 3. Okay, but now I want to say, okay, we change the divide by 3, become times 1 over 3. Okay, so we find out that when we multiply with a fraction, the progression gets smaller and smaller and smaller. And you can still go on. This is 11 over 27, 11 over 81, blah, 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 blah. It gets smaller and smaller because now we are multiplying with a fraction. Okay, so the first thing that I want you to know, I want you to change your mindset. Now we don't say divide by the number, we say times the fraction, which is the same thing. Okay, which is the same thing, but why I'm very stressing on the times the fraction, because later we'll talk about it. Okay, geometric progression, the pattern actually is all just times only, whether you times the number or times the fraction. So you remember, if you times the number, the progression gets bigger and bigger. If you times a fraction, okay, the number will get smaller and smaller and smaller. Okay, so that's a very important thing that we need to know. I want to establish at the beginning lah. Okay, today is just a beginning class only, so don't worry so much lah. Okay, let's try another one. Let's say this is give me a big number, 1792. Okay. Okay, 448. I don't know why I thought about this number. Okay, 112. Okay, so on and so forth. What is the next number? Okay, 28. Okay, how do you get 28? What is the pattern? Okay, very good. Okay, it's times 1 over 4. I know. Before this, I say it's what, it's divide by 4, but can. Okay, but I want you to change it into this way. So it's times 1 over whatever the number lah. So if it is divide by 6, it will be times 1 over 6. Okay, it's the same meaning. If it is divide by 7, it will be times 1 over 7. Okay, so why am I so like okay about this? Okay, because later when we learn the formula, okay, this number becomes very important. I only want times only, I don't want divide. Okay, so good that now at the beginning we change our mindset. Now we don't talk divide already. Okay, we talk about times 1 over whatever number that we divide lah. Plus minus no problem. Okay, arithmetic progression no problem. But this one geometric progression, everything is times. It's just times number or times fraction. Okay, so let's take a look at page 141. Okay, 141. Same thing lah. We're going to do the two network questions. Okay, question number 2. So here is the network. One. Okay. Circle, circle. Up here is the circle. And this is 2. This is 8. And this is 1 over 2. Okay, this is another circle over here. So, how many networks are there? 1, 2, 3, 4. Okay, so there are 4 networks. So the orange network, the red net. Oh no, cannot use red because I already have a red. Sorry. The purple network. Okay, 1, 2, 3. Oh, 3 you need. 3, 3, 3. Sorry. And the blue network. Okay, this is geometric progression. So be very careful. This geometric progression. So yeah. Okay, be very careful. Remember, it's all times whatever, times whatever. Okay, can you give this a try? And then also do the same lah, question B. Okay, do question B. I give you about 5 minutes to try, and then I will ask for your answer. Okay, try 5 minutes. Wow, nice. Okay, since Benedict already start, we will this one lah. Okay, he said the orange one is 136. Okay, 136. So orange is 136. Purple is 268. Pink is 16, 8, 2, and 1 over 2. Okay, 16, 8, 2, 1 over 2. Okay, first of all, I think this is correct. But now, maybe somebody else besides Benedict, can you tell me what is the pattern for each of this one? Orange is times what? Purple is times what? Pink is times what? Benedict, this is a geometric progression, no longer arithmetic. Okay, geometric progression. So no longer plus 3, cannot plus 3 minus 3 one. Okay, it's multiply, multiply. Okay, I tell you, the one that you got correct is, oh, actually, wait, hold on. Orange is 1, 2, 4. Yeah, okay, I think this is better. 1, 2, and 4. Okay, blue is 2, 4, and 8. Yeah. What is the pattern? The purple one is correct. So Benedict got this one correct. Okay, this one Benedict got correct, but you still have to tell me what is the pattern. What is the pattern for the orange? What is the pattern for the blue? And what is the pattern for the purple? Purple 32. Okay, very good. Purple is times 1 over 4. All right, very good. Half to 8, 32. Sorry, which one are we talking about now? Half to 8, 32. Oh, yeah, you're right. Okay, so actually, Charlotte and Simbury, yeah, thank you. So this is actually 32. Wow, Benedict, even I also kena tipu by you. Okay, orange is times 2, very good. And blue is also times 2, because 1 times 2 is 2, 2 times 2 is 4. 2 times 2 is 4, 4 times 2 is 8. Okay, this one, depending on how you read it. Okay, if you read it like Charlotte said 32, 8, 2 and half, then it will be times 1 over 4. But Sinbury, she read it this way. She read half 2, 8, and 32. If it is half 2, 8, 32, then it will be times 4. Okay, but the point is this, if the number is getting smaller, then you know that you have to times with a fraction. 1 over what number? Okay, but if the number is increasing, getting bigger, then the number will be times, that certain number. Okay, so it depends on how you read the network. So if you read it like Charlotte, okay, she read from 32 to half, it'll be times 1 over 4. Sinbury, she read it from half to 32. So it's times 4. All right, try the second one. This one a lot of fractions, so guys, be careful, okay? Be careful with this. Okay, let's see. Stephanie has answered. She said, Oh no. Uh, 1 purple, 1 over 3, 1 over 6, 1 over 12, 1 over 24. David also said the same thing. Very good. This is times half. Okay, then yellow is 1 over 3, 1 over 12, 1 over 48. All right. This one is times 1 over 4. Okay. Green is 1 over 12, 1 over 24, and 1 over 48. 1 over 12, 1 over 24, 1 over 48, sorry, 24. So this is times 1 over 2. Times 1 over 2, right? Yeah. And then the last one is orange, 1 over 3, 1 over 6, and 1 over 12. Yeah. Okay, this one is, oh, sorry, this is times 1 over 2. This is also times 1 over 2. Again, guys, it depends on how you read the network. Okay, if you read from 1 over 12 until 1 over 3, then it will be multiply a big number. Okay, so this is time. For example, this is times 2. Okay, 1 over 12 to 1 over 6 times 2, 1 over 6, 1 over 3 times 2. But whatever it is, whether it is a fraction or it's a number, okay, don't be afraid of the fraction. Okay, all you have to know is you want to divide by what number. If it is divide there, then you just change it to times 1 over the number that you divide. Okay, and that's how you complete the network. All right, let me go to another question. Take a look at question A. 1, sorry. Question said, determine whether the following sequence is a geometric progression and then justify your answer. So you see 1, 2, 0, 40, 40 over 3. The second one is 0 0.03, 0 0.003, 0 0.0003. Okay. Yes or no? What do you think? We start with A and B first. A, not B, yes. Okay. Benedict, since you say B is yes, tell me what is the pattern. If B is yes, what is the pattern? A, yes, B, no. Benedict said times 1 over 10. Oh. 0 0.03 times 1 over 10. Yeah, I know. We cannot use divide, correct? So you say times 1 over 10 now. So my question now is, why does Yvonne also say no? No. David also say that this is not. Is it or is it not? And then now Benedict say A is not. But both Yvonne and David say A is a geometric progression. Okay, Yvonne and David, if A is a geometric progression, what is the pattern? Times what? Now Wei Chen say both is yes. Okay, times 1 over 3. This is times 1 over 3 also. This is divide by 3, divide by 3. And actually, your both answer is correct. Okay, both is a geometric progression. Are you sure? Yeah, actually, both is a geometric progression. Okay, because this one, the pattern is times 1 over 10. Okay, times 1 over 10 times 1 over 10. Okay, that this one is times 1 over 3. Because it's divide by 3, divide by 3, divide by 3, divide by 3. Okay, so how do you know? Okay, how do you know that it is a geometric progression or not? So for example, in this question A, I will say, yes, it is a geometric progression. Okay, because the pattern is times 1 over 3. Okay, yes, it is a geometric progression because the pattern is multiplied by 1 over 3. This one also the same thing. Okay, how do we write this? We say, yes, it is a geometric progression because the pattern, okay, is times 1 over 10. Okay, this is how we will write this. Okay, but now I want to up your game now. We don't want to use the word pattern anymore. Okay, we want to use more mathematical words lah. So instead of saying the word pattern, okay, listen carefully. I'm going to teach you this because you're going to answer question. So instead of saying the word pattern, we change the word pattern to common ratio, because the common ratio, okay, is, and then we don't need to put the times anymore. We just put 1 over 3, 1 over 10. So if I were to ask you this question, tell me whether it is a geometric progression or not. If it is yes, then you say yes, it is a geometric progression because the common ratio is 1 over 3. I know, in your mind, you say, oh, pattern times 1 over 3. Okay, fine. But that's in your mind. But when you answer the question, you need to use maths words lah. Okay, so yes, it is a geometric progression because the common ratio. Okay, later tomorrow or another day, we will talk about this word common ratio lah. Okay, the common ratio is 1 over 3. No need to put the multiply already. Okay, common ratio is 1 over 3. That's why I said from the very beginning, now when we do the pattern, right, we only want everything times only. Is it times number or is it times a fraction? Okay, so for example, okay, so now what I want you to do is I want you to type out in the sentence for me lah. Okay, this you just choose one geometric progression and write down for me the answer. Yes, it is a geometric progression because can you please type it down so that I can see, just to make sure that you understand what I'm saying. Either one of these, you can choose number 1, number 2, or number 3. Just answer one only. This one, all 3 is geometric progression lah. I just want you to see the reason why. Okay, can you type it now so that I can see? Yes, it is a geometric progression because the common ratio is not times 2. We don't do the times 2 anymore. We just use 2 already. We take out the times because common ratio means times already. Okay, so good, Benedict. At least you know that that's where your mistake is lah. Okay, so everyone, if you look at the chat, Benedict's answer is very good, except that the multiply must take away lah. Okay, yes, it is a geometric progression. This one, I'm assuming you're answering number 1, although you never write the number there. Okay, yes, it is a common ratio because the common ratio is 2. Number 3, Charlotte says, yes, it is a geometric progression because the common ratio is 1 over 3. Very good. Okay, all right, excellent. Okay, one last thing, and then I will call it a day. So the most important thing now is we know that in a geometric progression, okay, the common ratio, the pattern, okay, the pattern is always the same. Okay, so so that's the most important thing. If the pattern is different, okay, for example, like this, 2, 4, 8, 16, and then after that 24. Okay, like that. Is this a geometric progression? 2, 4, 8, 16, then 24. And then after that 48. I don't know. Is this a geometric progression? 8 times 2, 16. 16 times 2 is not 24. Okay, so this is a very important thing. Sometimes a geometric progression, right, it looks like it's a geometric progression. This is 2. The common ratio is 2. This one is 2. This one is 2. But then suddenly this one is don't know what. Okay, don't know what. So, it's not 32. So you have to make sure, when they give you a progression, you have to check that every single pattern is the same. Don't just take the first 2 and then, okay, Kao Tim lah, is the same lah. Not necessarily, Sometimes it may not be the same. Okay, so be very careful with that. So if it is not a geometric progression, how do you write? Okay, you say, no, it is not a geometric progression because there is no common ratio. Okay, this one is 2, 2, 2, and then this one is suddenly something else. Okay, this is, hold on, this is actually times 1.5. So the common ratio is not the same. 2, 2, 2, and then suddenly 1.5. So it's not a geometric progression. Okay, so the two things that I want you to take with you today is number one, how to find out the geometric progression. Okay, how to complete a network. And then number two, if I give you a progression and I ask you to tell me whether it is a geometric progression or not, please know how to write the answer. Okay, if it is a geometric progression, you must tell me what is the common ratio. We don't use the word pattern anymore. Okay, we throw away the word pattern, we say common ratio. Okay, geometric progression. Okay, common ratio can be number, can be fraction. If it is a fraction, then the geometric progression will get smaller. Okay, if it is not a geometric progression, then you say because there is no common ratio. Okay, that's the most important thing. Okay, so that's it for today. And before I let you all go, so today your homework is very simple. I'm not sure how many of you have already taken this from the gut house. Okay, if you have taken this from the gut house, then I want you to page 14. Okay, page 14 in your what is this? Yeah, page 14 lah. Okay, page 14 in this one. I want you to answer question number 40 and 42 only. Okay, 40 and 42. Yeah. Okay. I want you to answer question 40 and 42, and then you scan or you take a photo of this one, and then send it into the Telegram group. Okay, so this is, now the problem is our Telegram group suddenly disappeared, right? Okay, so I will give you instruction on how to hand in your homework. Don't hand in Google Classroom anymore. Okay, so do question number 40 and number 42 and hand it into the Telegram channel. I will tell you how to hand in your homework. You can take a photo, you can hand in a PDF. If you take a photo, it's faster. Okay. Please don't look at other people's work. Okay, don't copy other people's work. Do your own work, and then after that, you can listen. So question number 40 and 42, by today. Okay, it's only two very simple questions. If you can answer the questions in our classes now, you can finish this by today. Okay?